Okay, so we'll start with pin diagram today. So which device we are going to use is 8089C51. Okay, that's S51, but although it's got the diagram is almost same. It is not almost same, it's exactly same diagram. Okay, so basically your 8051 is available in like different packages. What do I mean by different package is you can read this PQFP, TQFP, then PDIP, PLCC. There are basic type of packages. What does a basic type of packages mean? So PDIP pack. Okay, let me show you the PDIP pack of any IC. See, this is the package. Okay, this is how it will look in if it's in PDIP package. Okay, so generally ICs that you have seen that are in this package. That's known as PDIP package. Okay, that's dual line package. Okay, so there are two line of pins, so that's why it is known as dual line package. Then there are other packages also available. For an example, this PLCC package. Okay, so what is over there? The chip is like how chip looks would be different. Okay, so this is PLCC package. Okay, this is a SMD component. Like that, the pins are very small. You can see over here. Yeah, let me show it to you. You can see these pins are very small, so it's basically SMD type of package, and whenever that is being connected, like that is being connected on the your PCB, at that time it will look like this. See, this is also the example. So generally in your mobile phones or in a computer you'll see this kind of IC where the pins are basically shorter and that are directly connected to the surface itself. Okay, so uh, here the soldering is happen just beneath these pins and not on the other side of the PCB that we are used to do. Okay, that's different. So there are different packages. Okay, but mainly we'll be only focusing on this PDIP package because the pin numbers would be, it might be possible pin numbers are different in this case or this case. So whenever you buy any IC, okay, along with your IC number, you just have to check which package you have bought. Most of the time in market, if you go and buy the IC, most of the time this package will be available in the market to you. If you are a large consumer and you directly place an order, at that time you can go for this kind of package. So basically this package is used for development purpose, and then once development has been done, when manufacturing process starts, at that time this kind of packages are used. Okay, so very first basic difference, if you see, you have only 40 pins in this package and here you have 44 pins. So that kind of difference can be there. Even here 44 pins are there, so that kind of differences can be there, so you have to check that. Okay, so basically we are focusing on this packet, that's first thing. So now what is like 8089C5, how many pins it has? It has 40 pins. It's a 40 pin IC if we talk about PDIP package. Okay, so don't go for which package it is, just remember that it's a 40 pin IC. Later on whenever you need it, you can find this document, you can refer which package it is and how many pins are there in that package, but generally it is 40 pin package. Okay, or 40 pin IC. Even here you can see there is this NC. Okay, 1 2 3 and 4. So if you subtract it and there are two rounds, so that's why it is 44. Otherwise all the pins are same, but pin numbers would be different. It is possible pin number would be different. Let's check. See that pin number 1 is P1.5, and if you check here pin number is P1.0. Okay, so you have to check that, but right now we are only focusing on this package. And this is my pin diagram. It's very easy to remember. Probably that won't be asked in exam, that's I'm sure, because this is very easy to remember. See, what is it? We have 4 ports, so 4 ports, that means 8 pin per port. 8 into 4, 32 pins is occupied by port. Then one would be for your power and ground. Okay, so there are only like 3 or 4 unique pins that you have to remember, otherwise all the pins are very easy. So this diagram is comparatively very easy and it might not be asked in the exam. Okay, but please prepare, like go through it and prepare it. It is possible that I can ask it for like 2 marks or 1 mark. Okay, so now let's see what we have inside here. So starting from pin number 1 up to pin number 8, your port 1 is there. Okay, so see this part. P1.0, P1.1, P1.2, P1.3, P1.4, 5, 6 and 7. So whenever I say port 1, I am referring to this pins. Whenever I say port 1, I am referring to this pins. If I say P1.3, I am referring to this pin, P1.3. Okay, this actual pin. So this is my port 1. It's 8-bit port. So you have this 8 bits, and this port will be used most of the time for general purpose input output. The first preference would be with this port. Why? Because it does not have any other functional along with your port function, and other than that you don't require a pull-up resistor to be connected. We have seen that pull-up resistor is required for your port 0. Okay, but for port 1, pull-up resistor is also not required. So generally people will prefer to use this port for the convenience. Okay, so we don't have to bother about any other thing. That's the point. So if you are like working with limited inputs, in that case most of the time we'll go with port 1. Then there is pin named as RST. Okay, what's RST? It's basically reset pin. Again, how to like reset 8051, we'll see that below. That's eager for that, so we'll go through that one. We reach that. Then there is this port P3.0, P3.1, 2, 3, 4, 5, 6 and 7. So this is port 3. Okay, but along with port 3, now we will see something different is written in bracket. Okay, this parts. So what is that? That are the other functions, other duties that can be performed using port 3, and we'll go through most of them. So I am not right now discussing it. Okay, but I just briefly introduce them. This two, RxD and TxD, is related to transmission and reception of serial data. Okay, so RxD will be receiving pin, T for transmission. So TxD is transmission for serial communication. This INT0 and INT1 we have discussed about interrupt in 8085. Same way, your 8051 have two interrupt pins, and that two interrupt pins are this INT0 bar and INT1 bar. Bar is very important. We'll discuss on bar, like what's the function of bar. We'll discuss it when we learn the general purpose interrupt in 8051. Then this T0 and T1 are timer pins. Okay, so these two pins are basically timer pins. Whenever your timer is working as a counter, at that time this function, this pins would be used. And this WR bar and RD bar, we already know that that's a read signal and write signal that can be given to other memory. Now the question might be that if we have internal memory, we have internal ROM, that's 4 KB of ROM internally provided with us, then why we need WR bar and RD bar? So your 8051 can be connected to 64 kilobyte of RAM. Okay. Actually, you have been provided by 4 KB RAM or ROM, not RAM, ROM, but that's onboard ROM. But actually, you have 16-bit address bus in this case also. You have 16-bit address bus with your 8051. That means if you have a 16-bit address bus, that means you can connect up to 64 kilobyte of memory. Which memory? That's ROM. That's ROM you can connect. The size can be 64 KB, but we have only 4 KB available on board. So remaining 60 KB can be managed by in form of peripherals. Remaining 60 KB can be have like peripherals. Okay, so you can connect this in peripherals. So how it will be connected? Because this is your 8051, and I can connect external memory like this. I can connect external memory up to 60 KB. Even it is possible I can bypass this 4 KB and I can have 64 kilobyte of external memory. Even this 4 KB will not be at all used. I can connect external memory of 64 KB directly. It is possible. How and why we do that, we are not discussing that, but it is possible. Okay. So whenever we have this additional memory, at that time we need read signal and write signal to let the memory know whether I want to read or write. So to perform this read and write function, you have that RD bar and WR bar. Same pins we have during that 8085. Same way we have that two pins. Then on this side your 32 to 39 is port 0.0 to port like pin P0.0 to pin 0.7. Now keep this in mind. Here we are traveling at 1 2 3 4 5 6 7 8 9, and your port goes on like this 0 1 2 3 4 5 6 7. Also port 3 goes like that, like downward. Okay, but if you look at this port, this one, this is like written in opposite way, so like 32 33 34 30 and then 39, but the sequence written is altered. Okay, so here the order is descending, and on the port side the order is ascending. Okay, but that's only happens with this. So whenever you are writing in the question, answer to the any question at that time, please keep this in mind. Port 0 has different sequence of numbering. Okay, it does not go like ascending. So these are my pins. Okay. The other thing with port 0 is open port, like open drain port. Okay, so you have to connect an external pull-up resistor if you want to use that as an output port. That we have already seen why we have to do that. And along with that, you can see that in bracket it is written AD0 to AD7. So again, here we have multiplex address data bus. So if I am connecting external memory or any other external device, I will require address and data bus. I will require both. So again here with port 0, the other function given is address data bus. Okay. Now how to identify whether it's address or like data or some output function is used. So we have seen that during that port structure, we have seen that control signal was there. So if your control signal is 0, that means you have port functions, input output function. And if your control signal is 1, if control signal is 0, then input output function, and like not input output, I would say we are accessing something with address and data. Okay, but if your control signal is 1, then I am doing input output function on port itself. Okay, that means I have some device connected to port and I am accessing that device. But if the address or data would appear on that port, at that time automatically their control signal will become 1, and automatically address and data will be placed by 8051 itself. So you are not the one who is going to place the data, so it will appear automatically, and in that case you do not have to worry about anything. So this is the other function, and same way these are only the 7 bits of address and 7 bits of data, 8 bits of address and 8 bits of data. So we have completed with data bus. The same data bus we have, like address data bus we have with 8085. Same way we have a data bus over here, address data bus over here, and remaining 8 pins of your address like A to A15 is along with port 2. Okay, so P2.0 1 2 3 4 5 6 7 and all the address pins. So that's all about like ports. Then what are the remaining pins? You have your power up pin here, VCC, and your ground pin over here. So that two are that. You have this XTL1 and XTL2 where we are going to connect a crystal. Okay, these two pins where we are going to connect a crystal. And this is reset pin. How to reset it we will see. Then there is a ALE pin. See this ALE. Don't go with what is this program, but we have this ALE pin. We know the function of ALE pin. It remains same. Still, it remains same. Whenever there is an address on multiplex address data bus, that means this bus, at that time your ALE pin will go high and it will notify there is an address on 8051 address data bus. That's the thing. Okay. And then there is this PCEN and EA. So what are that? You will see. Okay, generally you are like whenever you do not have any hardware memory, like extra memory connected, at that time whether you are working with extra memory or not will be notified using this pin EA/VPP. Okay, uh, and PCN is related to programming. So let's quickly go through that. What are all the pins? Let's read it out. Like if there is something additional information is given. So port 0 is an 8-bit open drain bidirectional input output port. Okay, so we already know that why it's like that. As an output port, each pin can sync 8 TTL inputs. When ones are returned to port 0 pins, the pins can be used as a high impedance input. Okay, so this is we have seen that when we write one, the both the MOSFET turns off, and that's why we have high impedance mode. So that's why it is written like this. Port 0 may also be configured to be the multiplex low order address data bus during access to external program and data memory. So whenever you have additional memory or you are accessing external data at that time, this will be in hand. In this mode, P0 has internal pull-ups. Okay, so if you are like if we are controlling some external memory, at that time address and data bus might be sending one on port 0, but at that time that upper MOSFET will come into the picture and automatically it will be handled. So if you are connecting some extra memory, at that time you do not require external pull-up register to be connected with port 0. But if you are operating input on particularly not input even, particularly if you are operating output through port 0, at that time you must connect external pull-up registers. Then port 0 also receives the code bytes during flash programming and outputs the code bytes during program verification. External pull-ups are required during program verification. Okay. So what does that mean? This is related to when I dump a code. So I have my hex files on my computer and then I am sending that using a flip software. At that time, that's how like flash programming thing works. So at that time, what happens, that internal ROM will be cleared and we are sending that new data inside, and then we are verifying that program, like getting back that what has written in memory, and I'm going to verify it with my local machine. So that thing will be done through port 0 only. So it receives the code byte during flash programming. Okay. So this is not so important, so don't read this line. Otherwise this two are important, and you are supposed to write this in a description of port 0. Okay, but this is just related to, like, it's written in datasheet, so you must understand what is written inside datasheet. That's why I'm explaining you. Then let's go to port 1. Port 1 is an 8-bit bidirectional input output port with internal pull-ups. The port 1 output buffers can sync or source 4 TTL inputs. When ones are written to port 1 pins, they are pulled high by internal pull-ups and can be used as input. As inputs, port 1 pins that are externally being pulled low will source current because the internal pull-ups. Okay. What does that mean? When uh, as the input, port 1 pins that are externally being pulled low. Okay, so I'm connecting a ground to the pin externally. At that time, my uh, my pins will draw the current. Why? Because this is connected to ground and we have that internal pull-up inside. That's why that VCC will be flowing the current, and that's the reason. Okay, but what's the important when you explain port 1 is this part only. Okay, you have to write these 2 lines in your examination. That's important. Port 1 also receives the low order address byte during the flash programming and verification. Okay, so that's address basically, because we have that thing. So when programming, at that time your port 1 receives the address. Okay, so it's, even though it's not like address bus, then also it receives the address when you are dumping the code. But we are not worried about it because we are not going to design the 8051 hardware, so we are not interested in that. Then let's do read port 2. What's port 2? Port 2 is an 8-bit bidirectional input output port with internal pull-ups. The port 2 output buffers can sync source 4 TTL inputs. When ones are written to port 2 pins, they are pulled high by the internal pull-ups and can be used as input. So it is almost same as this, only that port 1 is replaced by port 2. That's only thing. Then as inputs, then it is continuing, going on up here. As input, port 2 pins that are externally being pulled low will source current. So again, that's the same thing. Port 2 emits the higher order address byte during fetches from external program memory and during access to external data memory that uses 16-bit address. This is the assembly level instruction for your 8051. This is one example of assembly level instruction. We are not going to discuss that what is it, but whenever we are accessing external memory, at that time this instruction will be handy. In this application, it is used strong internal pull-ups when emitting ones during access to external data memory that uses 8-bit address. Port 2 emits the content of P2 specific special function registers. We are not interested in this. Only line that we are interested is the first 3 or 4 lines that was written over here and this line. Port 2 emits the higher order address byte during fetches from external program memory and during access to external data memory. That's all. You just have to write this. Okay. You just have to explain the function of port 2 along with what's the additional function it performs. Then port 3, it's almost same. Port 3 is an 8-bit port with internal pull-ups. The port 3 output buffer can sync source 4 TTL input. When ones are returned to port 3 pins, they are pulled high by internal pull-ups. So everything is written same. The only thing that is different is this. Port 3 also serves the function of various special features. What are the special features? We already know. There is a serial input, serial output, external interrupt 0, external interrupt 1, timer 0, external input, timer 1, external input. Okay. So these are input pins. This one is input. See, these are the input pins: RxD, INT0, INT1, T0, T1. Okay. This 1, 2, 3, 4, 5 are input pins. This P3.1 TX is serial output. Okay, so this is output pin. When it is performing special duty, then and then, okay, we are going to study this in detail, like how that task is performed. In this WR bar and RD bar, we know that external data memory writes to and external data memory reads to. So you have to write this whenever a question is port 3 asked. So along with this information, you have to write this information as well. You have to prepare this table, like what are the other functions that can be performed. Then the pin reset. Okay, reset pin. A high on this pin for 2 machine cycle while the oscillator is running resets the device. How to have that reset circuitry? Let me show you the reset circuitry. It is not given probably. How to reset is not given. So let me draw a diagram how to perform a reset. See, whenever you want to reset, what you have to do is that's active high pin. If you see here, it does not have any bar. That means it is active high pin. That means providing 5 volt will reset that thing. So how to reset your 8051? If you want to reset it, what you have to do? So you have to connect an hardware with 8051 to reset it. Okay, so let's see what that hardware. So suppose this is your 8051. This is my VCC and this is my ground pin. So I am going to connect a ground over here and I am going to connect plus 5 volt at VCC. And now let us say this is my RST pin. So how I am going to connect this pin? Okay, what I'll do, I'll connect a push button over here. This. Okay, and the other part, the other line will be connected directly to ground. So whenever I want to perform reset, what I will do, I will press this button. Okay, but as soon as you press this button, see what happens. As soon as you press this button, what will happen? All this plus 5 and this ground will create a short circuit like this. That's why what we do is, instead of directly connecting this line like this, we'll connect a resistor over here, which will limit the current flowing to the ground. Okay, this would be somewhere around 10 kilo ohm resistors. I'll give you the exact number, like what's this resistance. How to get like what resistance should be connected, that values depend on the capacity of this pin. Reset pin current capacity would be written inside somewhere. Let me show it to you if I can find it. Yeah, see this value is written over here. See, you can read it, reset pull down resistor. Okay, so reset pull down resistor should be 50 to 300. The unit is kilo ohm. So this is the minimum value and this is the maximum value. Okay, so it's larger, not even 10. It's almost 50k to 300 kilo ohm resistor. You have to connect a 50 kilo ohm to 300 kilo ohm resistor over here. Okay, so let's consider we are connecting 100 kilo ohm resistor over here. So you require 100 kilo ohm resistor along with a push button. So whenever I press this push button for two machine cycle, okay, like 2 ticks of clock like this, I have to press it for this time. Okay, what is this time? We are going to calculate what is this time. Okay, it would be 2 microseconds. How I know that? I know that from experience, but it would be somewhere around 2 microseconds or even less than that. But we have to press that button for that amount of time. Okay, so as soon as you press it, immediately a reset will happen. Okay, and this is a limit resistance, current limiting resistance. That means you do not like directly connect plus 5 volt to ground. What will happen otherwise? Infinite current will flow. Okay, because the resistance is almost zero. So if you say 5 by almost zero, let us say this, then a huge current will flow and that will damage the IC. So that's why we connect this resistance. So this is a reset circuitry. Okay, very simple. A connect push button along with a resistor. Resistance is almost 50 to 300 kilo ohm, and you are done with your reset circuitry. Now let's see what other devices you are going to connect. See, I directly teach you from this data set. That means something good is about this thing is this is the source of my information. Okay, so whenever you want to design any embedded system or you are designing any system based on some IC or electronic components, at that time you need datasheet. Various datasets are available. For example, this is dataset of 8051, but even you use 7805. For example, you are using 7805. What is 7805? It's your voltage regulator, 5 volt voltage regulator. So if you search for this, you will get a data set like this. Why this data sets are important? You have to particularly go with the version you have. So there is IC number written on your IC. Refer that and search for that particular model. So why it is very important? So many information is given over here. See, these are the package information given. Okay, and then the packet thermal data, like what temperatures ranges it can handle, then recommended operating condition, like in which normal conditions it will operate. Okay, what are the minimum and maximum input voltages? So you cannot blindly like apply 30 volts to your 7805. Okay, there is range, and that range is depend on this series number. This series number or part number would be written on your IC itself. Okay, if it's 7805C, then you cannot go beyond 30 volt, on at least you have to provide a 7 volt. So if you are operating it on 6 volt, it might malfunction. Okay, you might get 5 volt, you might not get 5 volt. But if you want a perfect characteristic like perfect 5 volt, then you must connect 7 to 25 volts. That's how you read this thing. That's why datasheet are meant for. So this is provided by manufacturer. Okay, manufacturer knows the parameters of his IC. So he provide this document, and this document is the base document for anything. Okay, then output current. So here no minimum range. Okay, so nothing is written on minimum, but maximum is written. That means it can provide maximum 1.5 ampere of current. Operating virtual junction temperature. Okay, so you can drive this IC up to 125 degrees thing. Okay, if it's going beyond that, due to your operation, you have to connect a heat sink and you have to maintain a temperature below that 125. This is the maximum. Okay, you cannot operate it on -1 degree, 2 degree. It might operate. This is just a recommended operating condition. It might work, it might not work, I'm not sure. Then there are electrical characteristic given. Okay, when it is given, see, input is 10 volt and output is 500 milliampere. At that time, this parameters are noted. Which parameters? So output voltage, okay, at junction temperature of 25 degree and 0 to 125 degree, what's going on inside your IC, that's given. Then ripple rejection input. So every line over here has some meaning. It might not helpful for you right now, but if you are embedded system designer, if you are in a job in future where you have to design that PCBs on something, at that time you have to read all these parameters and you have to understand all these parameters. Okay, then and then you will be able to design things. Okay, so that's why this thing is important. That's why we refer datasheet. Datasheet is like Gita for that instrument. So right now we are discussing about 8051. So let's come back here. Then your ALE. So address latch enable output pulses for latching the low byte of address during access to external memory. What is this? What is this system? This is just the thing that we have read in 8085. Whenever there is an address on address data bus, at that time LED will provide you a signal or a high pulse which will notify you that there is an address, using which you can latch the address using 78 LS 347. That was the IC latch. Using that same latch you can latch this address. Then what is PROG bar? This pin also program pulse input during flash programming. So this is the pin which will be used during flash programming. So we are not going into that. In normal operation will not require. You just have to write this thing. Okay. You can use a different language, but that point should be covered. Then PSEN, program strobe enable. So whenever you are having external memory at that time, this pin will strobe the external memory. During external memory intervention, this will be used. Okay, so we are not going to that. So we are not going into the detail. One more function is given to PSEN. Is PSEN can be used for one version of 8051 when you want to flash program it. Okay, and right now we are not discussing that function. That's why I'm not going into that PSEN. But later on, I'll explain you whole circuitry. So if you want to build your own board of 8051, you can do it. So I'm going to explain the whole circuitry, like what are the essential components, and I'm going to explain again with like values. So if you connect that number of things, you can have your own board on which you can program or on which you can perform different tasks. So at that time we'll see PSEN again. Right now we are not going into PSEN. Then this is external access enable. Okay, so if you connect a ground to this, okay, what will happen? Your entire memory, like entire 64 kilobyte of memory, will be accessed externally. That 4 kilobyte internal ROM can be discarded. So I have explained you earlier this. If you do not want to use your 4 KB RAM, you can do that. Okay, how to do that? By connecting ground at this pin. If you connect EA with the ground, automatically that will be activated. That means external memory would be used. External 64 KB memory will be used instead of this internal RAM. That's the pin. So you are directly connecting this to ground. And if you want it to be programmed internally, at that time you should connect this EA with your 5 volt. Okay, and what's the other thing? We are not going in that, but external access enable pin is important. And then your last two is XTL1 and XTL2. These two pins are where we connect crystal. This is how crystal is connected. Okay, even the values are given. For C1 C2 you can have this 30 picofarad crystals. Okay, so if you have this crystal, there are various type of, like, this is known as oscillator basically, and there are various type of oscillators available. So if you have a crystal oscillator, in that case you have to connect a 30 picofarad capacitor. C1 and C2 should be 30 picofarad. And if you are using a ceramic resonator, that's other device. Okay, that's not crystal, that is ceramic resonator. Again, that's kind of oscillator. It can generate a frequency. In that case you have to use a 40 picofarad capacitor. Okay, so how this connection is made? You are going to connect a crystal between XTL1 and XTL2 along with two capacitors at the end, and then both the end of capacitor is connected to ground. So this is how you connect a capacitor. Done with the what we can say, pin diagram. Okay, then some modes are explained over here. I'm not going into that. I'm going to have one more data sheet from which we'll refer these things. Okay, so this is all about your pin diagram. Now let's move on to the new topic, and that is timer. So very first basic question is, what is timer? Why is timer? So there are like few questions that has to be answered. First is, what is timer? why we need it, and how to use it. If you solve this three questions, you'll be able to explain timer to anyone. So we have discussed when we were generating time delay. Okay, how we have generated delay using for loop, and we know that using for loop, you cannot generate accurate time delay. What do you mean by accurate time delay is also important. If I say 250 millisecond time delay, then I cannot able to do that exact 250 millisecond using for loop. That's what I mean. Even calculation is very complex, so you would be having a troubleshoot method where you will check with different numbers, and at the end you will get 250 millisecond. So that's the way how can it be possible, but you cannot do it with a for loop. So to solve this kind of query, to have this kind of exact time delay, we have timer. Okay, so what is timer basically? So timer is basically two resistors. The resistor name is TH and TL. I am going to modify this two name as THX and TLX. These are two resistors. Okay, so whenever what is timer question is there, timer is actually a 16-bit resistor. This 16-bit is 8-bit of THX and 8-bit of TLX combinedly making 16-bit. Timer is 16-bit resistor, okay, which will increment on each pulse given to it. So basically it's kind of a resistor which can increment. When it will increment? When I provide a pulse like this to it. Okay, so whenever I provide a pulse, it will increment by 1. Okay, so right now let us say my timer value is 0, 0, 0, 0. I provided a pulse, it will rise up to 0, 0, 1. Then I'll go with one more pulse, again it will become 0, 0, 0, 2. So how I am going to provide this pulse? That's a next question. Okay, so we have solved first two questions, like what is timer, why we need it. Why we need it? We need to generate accurate time delay, and to generate accurate time delay we need a timer. What is timer? Timer is a 16-bit resistor using which you can generate accurate time delay. Okay, how I'm going to generate accurate time delay? We know that on each pulse my timer will rise with 1. Okay, on each pulse it will rising with 1. Okay, so now let's see how exactly timers work. So basically what I'm going to do is we'll go a little bit, like it's a big diagram, but we'll go step by step and we'll explain like we'll understand what is timer. Let us say this is my timer. Later on I will replace this timer with something else. Let us say this is my timer. Okay, what is timer? Timer is basically a 16-bit resistor. So let us say this is a 16-bit resistor. So what can a 16-bit resistor have? It can have some values. Okay, let us say right now the value is 0, 0, 0, 0. So it has one input. Okay, so what I'm going to do? I'm going to provide a pulse through this input pin. So whenever I provide pulse, what will happen? It will increment the number by 1. Okay. So whenever there is a pulse like this, it will increment a number like this. So what I'm going to do? I'm going to give a pulse train directly like this. So what will happen? Here it will increment by 1. Okay. On each falling edge it will increment. No, it will increment on each rising edge probably. I have to check on that whether it's a rising edge or falling edge. Okay. Let me quickly check it whether it's a rising edge or falling edge. Okay, it is a falling edge. So basically, whenever there is a falling edge of this pulse, if this is a pulse, when it will increment only on this point. on transition from 1 to 0. Okay, so this is first transition, so it will increment by 1 at this point. Okay, this is my first increment. Here it will become 0 0 0 1. Then at this point it will become 0 0 0 2. At this point it will become 0 0 0 3. At this point it will become 0 0 0 4. Okay, so on each falling edge it will increment by 1. Now if you look at this, you have seen this diagram earlier. What is this? What is this? This is my frequency. Okay, this is my frequency of what? This is my crystal frequency. So actually I am feeding my timer from my crystal. So what I am doing is I am feeding my timer from my crystal. Okay, so now I can change this diagram to a new diagram and it will look like this. So I am changing it and now it will look like this. So this is my crystal, okay, and crystal is connected to my timer. So now see what happens. Now crystal generate a frequency. We know that it generates this kind of frequency. So now what will happen on each falling edge? It is rising by 1. We know that. Okay. Now if I ask you what is this time from one falling edge to other falling edge, from one falling edge to other falling edge, is this time fixed? Is this time fixed? Anyone can answer. What is the time between two falling edge and whether the time is fixed or not? I have that two question. If anyone has answer, can answer.
Not fixed.
Not fixed.
No,
Why?
sir, not fixed.
Why it is not fixed?
Each and every time we provide a delay between the signal.
What signal is this? This signal is generated by whom? I am not going to
Crystal.
generate signal.
Crystal.
This generated by crystal. Okay. So generally whenever we say crystal, along with crystal we ask one more thing, and what's the frequency? So we say 12 megahertz. So if it is a 12 megahertz crystal, that means uh, like whenever we associate something with frequency, that means it must be a periodic and very accurate. Then and then we associate with frequency. For an example, if I say 50 hertz signal, what does that mean? That's a sine wave like this. Then why we say it's 50 hertz? Because the time period between these two is fixed. If it is varying, then I cannot declare it in terms of frequency. That's the first point. That means if something is fixed, like some time period is fixed between two pulse, then and then I can declare that's in frequency. Okay? Because it's in definition of frequency. If you search for the definition of frequency, let's do that. What is a frequency? Frequency is the number of occurrence of a repeating event per unit time. It is also referred to as temporal frequency, with emphasizing contrast to spatial frequency and regular frequency. Frequency is measured in hertz, which is equal to one occurrence of repeating event per second. Okay? That means what does that say is basically only that thing have can frequency which is repetitive in nature. If something is not repetitive in nature, that I cannot say it's in frequency. For an example, student entering into the class. Student entering into the class. Can I declare them in frequency like one student per minute? Can I declare it like that? No, it's not sure. Like the 5 students can appear in a single minute, and then one can appear at the 2 minutes later, and even someone can get 10 minutes later. So this kind of event I cannot assure. I'm not assured about this. But if there is a crystal is vibrating inside, and due to that only you are generating frequency. Okay, so whenever I say a crystal is generate frequency, at that time this frequency would be very accurate, and this time period between two would be fixed. Now next question. If this time is fixed, let us say I have a 12 megahertz crystal. Can you calculate the time? Can you calculate time between two pulse? I need yes from all the students. Can you calculate time between two falling edges? If its frequency is given 12 megahertz is the frequency. How you calculate a time between two repeating event or two occurrence? Like when we declare something as a frequency based on time period, when we say time period, when your cycles start to repeat at that point, we'll say time period. For an example, let's discuss about this 50 Hz signal first. We'll say sine wave is periodic in nature. Why we say it? From this point to this point, it's unique. All the values are unique. But as soon as you reach this point over here, after that, the values are repeating same as this values. That's why we say time period is this. Okay, after this much of time, my signal will repeat. Can you observe same property over here? My signal is repeating after each between each of this. Say from here to here, you can say, or even you can say from here to here, between two rising edge or two falling edge, you can say it. Same way I can say my signal is repeating from here to here. Like I can say this is my time period, although the time period would be same way here. If I draw a square wave like this, let me explain to square wave. So this will become my time period. This will become my time period. This is my t. Is there any relation between t and f? Is there relation between t and f? This is f for frequency. Time for
F is equals to 1 upon frequency.
t is equal to 1 by f. That's the relation. So can you find out this time? Yes, you can do it. How you can do it? 1 by 12 megahertz. Okay, then I'll get something in seconds, and that's the time. That's the time I require. Okay, now let's calculate what's that time. 1 divided by 12. Sorry, 1 divided by 12. 0.0833. So let us say it is 0.0833 microsecond. Okay, so now I can say each pulse like this pulse after this pulse, that two pulse is 0.0833 microsecond apart. Can I say that? Yes or no?
Yes.
So if you can say that, then you can also say that if I am incrementing this, like if timer is incrementing on each pulse, so if the value inside the timer 2, if the value inside this timer is 0002, I can say that the time passed, like the time that has been passed is 2 into 0.08333. Can I say that? ऊपर थी समझाओ.
Yes, sir.
Can I say that or not? I need answer for everyone. Again, see, I can say one pulse. From this pulse to this pulse, time required is 0.0833 microsecond. Okay, sorry for that. The time required is 0.0833 microsecond for one pulse. So if I have 10 pulse, what is the time? If I have 10 pulse, what is the time? It would be 0.833 microsecond. Correct or not?
Yes, sir.
Everyone.
Yes, sir.
Okay. So
Yes, sir.
so you can say this timer is basically actually like incrementing by 1, but this increment is periodic in nature. Like I can relate that increment with time directly. Okay. The increment happening inside here is directly related to time. I can say that or not? Yes or no?
Yes, sir.
You can say no, no issue. If you say no, I'll explain you tomorrow again. Okay, we'll stop here for today. I think you are fed up for today. We'll again start with the same thing. You first have to understand this concept, and then we can, like, you can understand timer. It's very easy, not at all complicated. This is very easy theory. This is like as simple as maths. But we'll repeat it again on Monday. Thank you. You can leave. If you have any question, you can ask.